the work showing today is only vaguely related to space syntax. It's about classification and about urban people morphology, so rather general. So people morphology, as you all know, is the classification of urban forms derived from the typical structures and spaces. In many scientific disciplines, classification is super fundamental, not only in architecture or urbanism. But, however, urban people morphology has never, or is very, very far from attaining the high levels of rigor and systematization that are common on those disciplines. And well, problem seems rooted in several aspects. First of all, which attributes to consider, which the degree of resolution of classification, and above all, what are the classification criteria themselves. There are other drawbacks in traditional morphological studies because they are rather time-consuming. They are not very clear. They are, well, rather subjective. They are based mainly in ability of the person that is doing the classification. They are very context dependent. They normally don't apply in other situations from that where they're being derived from. They are hardly reproducible and generalizable. And furthermore, they pertain mostly to traditional urban settings. So they seem unfit to address contemporary metropolitan. So nowadays they seem quite not very relevant. But to go to these difficulties, we propose a different method for defining people morphologies, which is the use of unsupervised classification techniques, which are actually the kind of methods that are used in many other scientific disciplines and have become totally paramount to those disciplines, and probably the levers upon which those disciplines advance today. They try to find homogeneous groups of observations in a data set regarding a certain number of attributes. But what is more relevant, the classification is derived only from the data itself. So there is no reward final provided to the method so that the classification may be derived. It's only the structure of the data itself that gives rise to the classification. So if we apply this to urban typical morphology, we can have several advantages. First, the classification, if several procedures are taken into account, may be rather consistent, objective, and reproducible, because the method is linear. They use computerized data analysis, so they rely upon computers, so a large number of attributes may be included, and also very large samples may be analyzed. And because they look only to the data, they may reveal the intrinsic and real nature of local types, while allowing for the discovery of previously unknown types without relying on previous typical morphologies. So what I have used is this very well-known K-means algorithm, which I will explain very quickly. Imagine a set of objects, objects to be classified. One needs to define initially the number of classes that one wants to attain. In this case, 3. 3 points are selected randomly, and all the points that are near to each one of the random selected points are an initial cluster. And then this is an iterative process in which each centroid is relocated in the mean point of the so-defined cluster, and then the points that are more near to the new position are again well, classified as a new cluster, and this goes on until the centroid of the cluster doesn't move anymore, so the ideal classification has been obtained. So this is the method that I have used in trying to classify what I'm going to show now. This is the study, so Porto Metropolitan region. This is Portugal. It's there. Over these, I have drawn an actual map, which is well, really the only connection that this work has with space syntax. But any other kind of street network could be used. For instance, road center lines. The reason that I use an actual map is because of the larger research of which this is part, but any other kind of representation of streets could be used. The map was redrawn over several periods using a very simple method in which the occurrence of each line in each period is recorded with an attribute. So this is reconstructed in several periods, so producing the network on several historical moments, which are those here represented there. And of course, we can also extract the subsets of lines that occur between each period. And we can also look at those subsets over orthophotographies in order to quite easily identify the urban developments, the individual urban developments to which each set of lines describing the street network of development belongs. This is, even if quite laborious, it is an easy process because this tends to occur always as separated clusters, so one can very easily see that this is one thing, that is another thing, that is another thing. There are some more complicated situations, but looking at roofings, well, pavements, architectonic style, and things like that, one can isolate these. That's what I've done, and so I've produced this large database of 4,208 individual urban operations occurring within the study's time span. And what I have done is to classify these street patterns according to a series of morphological attributes that I'm going to describe now, using these two conceptual grids, of course very different one from the other. This represents the existing grid, and this the urban development. And I have used this set of attributes. Something needs to be said in relation to this, because the only part of the method that is variable is actually which attributes to consider. So this will determine the end solution. And of course this is open to discussion, but I have focused on two properties, geometrical and topological properties. So I've counted numbers and types of junctions, T junctions represented by these yellow circles, and X junctions, or 4-degree junctions, internal and external, so those linking streets from the development or linking to existing streets, the number of internal blocks or cycles, and the number of external blocks or cycles created by the intervention together with the existing grid. So this was the raw data, and over this I've still calculated some ratios. For instance, the number of segments over the number of actual lines, the area perimeter ratio of internal blocks, and so on. This has all been done automatically and semi-automatically in GIS, producing, of course, a table containing all these variables for each object. Each line here corresponds to one of these things. And also important, because one of the main ideas of this work, these are all completely market-driven interventions, so absolutely non-planned, eventually designed, but designed for completely non-coordinated agents. So we have this set of variables representing configuration and composition or geometry. The configuration of variables may be divided into external or internal, meaning that these describe properties that are related to the existing grid or to the development plus the existing grid. These pertain only to development, and these are only internal, so geometric variables. Many of these variables are correlated, so we made first a screening of these and we eliminated some. And these are the distributions of these variables. As you can see, they are all very right skewed, so full of outliers. But the logarithmic transformation is able to normalize this and stabilize the variances in most of the variables except some of them, namely these three. This one describes the number of internal X junctions, the number of internal blocks, and the area perimeter ratio of the blocks. These two being quite related, of course. As you can see, there is a very large peak of interventions that don't have blocks at all, internal blocks. And also a very large peak of interventions that don't have internal X junctions, which are also obviously related with the presence of blocks. So this suggests yes, and outliers are quite deleterious for any clustering exercise. They can just produce solutions that are meaningless. So we need to take care to be cautious with outliers. So this suggests the first initial division into interventions with internal blocks and interventions without internal blocks that are termed cellular and linear. And you can see that this very simple and straightforward separation is able to actually normalize many of the previous very right-skewed variables, except also in some cases here in the linear set. And if we look closer at these, at what those outliers are, they are mainly the evolving highway network of Oporto. And some other very large linear interventions. And these are, of course, planned interventions. So they should not be subjected to the clustering, which is the objective of this. Because what I was looking for was to classify all these market-led, very strange, all different developments, and not actually things that are planned with an intention and which entail a large amount of money to build, and above all, which are of course planned, so that there's no point in classifying motorways and things that have a clear planning intention. So there's another basic separation that you can do between incremental, meaning things that are done privately, market-led, step by step, and non-incremental interventions, or for instance an highway that is built all the mass. So if you check the behavior of these things, this represents, these radar plots represent the mean value of all interventions in these subsets on each dimension of those morphological variables that I've described before. You can see they are all quite different. So this was the second, because the first was division between linear and cellular, a second basic distinction. And then actually I used for final classification the K-means algorithm, classifying all interventions from all periods at once, in order to check afterwards the temporal variation of that classification. But using a hierarchical classification, you can see that the objects for all periods are rather classifiable as 4 clusters in each case. So this summed up to this final scheme, in which we have a set of large interventions in which size, which is this variable here, is the most discriminant variable. So these developments are first divided by size into large or small, and then we have that first division of linear and cellular. These two things were classified separately, and then we have this next classification, which well emerged from the exercise, which are I call conjunctive or disjunctive interventions. These are mainly characterized by conjunctive interventions. These are the variables that represent the external relations of each intervention have I values here. So these are developments that are well connected to the external grid. And disjunctive interventions are operations that are done, they are done planned inwards only. So they connect in one or perhaps 2 points, and they only have internal structures, so to speak. And here you have a series of examples of this. Here we are looking only at linear interventions. And I don't know if it is apparent from there, but they, let me explain just a little bit. So we have here large ones. You can see that they don't have internal cycles. These white lines represent the existing grid. They create blocks and cycles, but only by conjunction with the external grid. They don't have internal cycles. And they are very connected. You see, these are the external connections. They have lots of them. And this is the same, only they are much smaller. For instance, with a great economy of lines or of streets, you can see that here I created, for instance, three new connections between existing streets. And in the case of disjunction interventions, we always have lots of cul-de-sacs, which are these, or dead ends, which are these blue circles, and we have very few connections. For instance, here only one, here only one, here two, but in comparison with the number of cul-de-sacs, you see that this is very inward-looking structure. And regarding the small ones, the kind of structure is exactly the same, only the size is smaller. Sorry. And regarding cellular interventions, it is exactly the same, with the only difference that they have internal blocks. For instance, here, and also the same distinction by size is quite apparent. For me, I hope that for you too, I think that the kinship between these forms is quite apparent, even though they are all different. So this is actually capturing some kind of regularity which is not immediately apparent to the naked eye, but that when we look with attention to the variables that were considered, there are actually different families in which the members have an actual kinship. So this then has allowed me to produce this taxonomy of street patterns. This is not a clustering thing, it's just a way of ordering all this. And here you have another set of examples. So we can divide all incremental interventions into very large kind of small and large interventions that can be divided as cellular, linear, and then as disjunctive or conjunctive. And so we can just term them by these three levels, three morphological levels, as for instance small cellular disjunctives or small linear conjunctives. So having this done, I have then looked at temporal variation of this. Size and simplicity are not very discriminant things. Regarding size, what you see is that through time they become larger. There is initially, it is a kind of explorative process. It looks like developers initially make small investments, and as time goes on, as the Metropolitan region grows, bigger things start to appear. But that's all we can say about that, and of course size is not, well, it's rather vague variable. Regarding simplicity, what we can say is that interventions with internal cycles become more frequent through time. But what we can actually say is that interventions that have internal cycles are extremely scarce. I have no answer for this, but it seems like, at least where I come from, building blocks intentionally or within the grid that is being produced in each development is rather rare. Blocks are, of course, built but by the subdivision of the existing grid, not by the creation of blocks by itself. But regarding connectivity, that is disjunctive or conjunctive interventions, there is this quite interesting variation, in which in the first period, conjunctive interventions are prevalent, but then they disjunctive become prevalent, and then this shifts again. So, of course, the choice of building something that is well connected to the existing grid or not is rather purely a design choice. This has probably to do with prevalence with modernist forms or something like that, but this is actually a purely design choice that apparently varies greatly through time. I have not explained what this is. These are the shares in terms of raw count, so only the number, the simple count of each class divided by the total number, or no, as a percentage of the total number, sorry, but there is a percentage of the total road length constructed. And you can see that both things are quite the same here. So I looked a little deeper into this conjunctive-disjunctive conjecture and dividing large cellular, see what happens, small cellular, well, organizing this by cyclicity and by size. And you can see that the pattern is recurrent in all subdivisions, always with this peak of disjunctive interventions are always more during the second period of analysis. So this varies through time, and is actually, I think, useful to know that. And another thing that is useful is to know the actual morphological nature of these things that occur in a non-coordinated and totally market-led way. So, as a conclusion, we started with 4,208 individual things, very difficult to say or to classify, to say what they are or to classify. And we end up with just 8 morphotypes and with some taxonomy of Metropolitan street patterns. There is an hierarchically organized classification. And this was achieved by simple statistical analysis and by objective methods, which can be reproduced easily. They correspond to novel, well, and eventually unexpected, I don't know if you think so or not, contemporary metropolitan morphologies, which will be difficult to identify otherwise. And they have shown to have clear different temporal frequencies, revealing that these things don't simply occur randomly. There are trends in the production of street patterns. And, well, as a final output, I would say that they are liable of informing urban planning and design, which is actually a problem with classical typomorphology, because we can make a plan based on a hunch of a classification that are based on hunches, but, well, it's rather guessing, I think. But with these kind of methods, we can actually know that these things actually occur with statistical significance. And moreover, of course, this is context independent, because if I end up with this kind of classification here, the method can be used in any other kind of context, allowing for, well, this can be made in very large scales and quite systematically, so allowing large comparative typomorphological studies. That's it.
I think it's very interesting to try and come up with a classification of morphological types, as you understand that I like that, probably, knowing my work. I have two things. One is that you have to be, let's say, precise in how you call them. Now you gave them the name, let's say, what's in them, but what I mean actually is that because now you say you have 8 morphological types, but actually you have types of street patterns, because morphological types would be much more rich. So be precise also with that. If you want to be precise in your classification, you have to be precise there as well. But actually what I think would be extremely interesting if you take the next step and talking about performances. So how do these different types perform? Because then, let's say, they become very, very important in how you roll.
But that is much more difficult to say. But you can only say that. No. It's a completely different issue, and you can only say that starting from a classification that you can, where you can stand. Right. This is just a step in that direction. Because assessing the performance of these different types is it's a different thing. I completely agree with you. I'm just saying that it's beyond the scope.
No, absolutely. But let's say I say it because I think that they increase in importance to start using them. And one very simple first step you actually started with it is of course to talk about connectivity. There are very simple first performances that you can describe and see whether they perform differently or not. Instead of ending up with the types.
Yeah, but what I'm saying is, I will, by gut feeling, saying that conjunctive interventions are better than disjunctive, right? Connect with high connectivity is better than low connectivity. But I don't know. I'm just guessing. But I know that's not what we're talking about. We're talking about a systematic assessment. What I'm saying is just that should be done on the basis of some rigorous classification. This is just that. Yes. But just one comment regarding also the names. The names are not very important. We can as well call them A, B, C, D, or what is important is the numerical definition of these things. So they may be defined, and on that sense they are quite well defined by the range of where variables are located for each one. You see, and actually that can be used afterwards for classifying new things that are appearing. You can use that, we can call them a morphological vector, that series of numbers which characterize each class to classify new things that appear. Okay? Yes, I agree that names are rather arguable, but actually the numbers are more.
Yeah, but I was not talking about the names of the different classes.
You're talking about the morphology, exactly. Yeah, of course. But in the title it says.
Okay. It does.
Just a quick comment. I haven't read your paper, so you probably speak in there. But have you referred to the work of Stephen Marshall's about state patterns?
Yeah, of course. It's a basic reference.
Okay, sorry.
But in the paper, it's well cited.
Yeah.
I think this is maybe another way of getting at the same concern you had, and that's how can you be sure that those clusters actually mean anything? I mean, any data set you have, you can cluster, you'll get recognition, especially by k-mean, because you set the number of means and you're getting clusters. So how can we be sure that they're actually defining something that's of real importance in the...
Okay, as you may well know, there are several methods of assessing the clustering solution. And, it was not shown here. But first, there is one thing, is the visual. Those things, those examples that I've shown are the archetypes of each cluster. So they are the object normally to the center. Okay, and looking at them, I think you can say something about that. But of course, like I was saying, there are several tests and ways of assessing the clustering solution. And one of them is
No,
just
that's right. I'm
looking at
not
those
talking about the
values.
clustering solution. I'm talking about whether the clusters you found actually say something meaningful about those particular patterns in an urban context. But I think that's what you're talking about in terms of performance. It's not just about clustering the data that you have, but you selected the data, and no matter...
Meaningful in what sense?
Meaningful
What I'm
in terms
saying
of-
is that they are actually different. Not only by looking at them, but
they're actually clusters that really appear in that particular data set, but you've selected that data set based on a series of measures that you could pick.
okay. But I have made that proviso. This, of course, depends on the initial variables, and that is completely open to discussion. If I had chosen other variables, for sure, the result would be different.
So how can you be sure you chose the right variables then? And that those clusters are actually meaningful?
Well, my reply is just, I am sure that they are meaningful regarding the variables that I have chosen.
Right.
And I don't believe, it's not circular, it's just a reply. I don't think that there is any way of unsupervisedly choosing the variables.
So
the variables were actually chosen very much based on Marshall's criteria on configuration and composition.
Yeah.
So, and also the variables that were used were after a screening of a larger set of variables that were, well, autocorrelated, so they were just thrown off. But yes, like I said, this as a loose point, and the loose point is that it depends on the variables.
I don't think that's quite satisfactory yet. And actually, what I would suggest is that, I'll give you a reference later, because there is some work that one of our students did a few years back, and it suggested that for other similar sorts of studies as you've done, the set of variables that you choose, no matter what subset of variables, or a large set of variables you choose, if you choose a big subset, you'll almost always get the same classification, which does suggest that something other than just your arbitrary selection of variables is always converging on the same kinds of clustering, which might be an interesting way of checking.
Yes, which is a
establishing
stability
something
of the
outside
regularity.
your own choice.
Yes, okay. You will tell me what work is, because yes. But can you just explain again? So
well, this particular work, and it might be the same. You selected a series of variables. It was I think 8 or 10, depending on the.
Yes.
Yeah. So you selected a series, but you could have lots of other variables you could measure. So what this particular student did was to select varying. Well, she did this initially. The ultimate account is that no matter what subset, if you choose a set of 8 or 10 variables, it will always converge to the same set of clustering, even if you choose a different subset.
Is that basically because everything's autocorrelated?
No, it's not autocorrelated.
I think
It suggests.
I'm doubting whether that's a solution.
Well, I don't know what it would be, but if it were to be the case, then it would suggest that there is something aside from the arbitrary selection variables, which would be nice to see. I don't know if it's the case with this, but if it were,
It would be nice to then expression the initial set. This one is
yes.
good my expression that you only selected from those 1,000, why didn't you select another one?
Another 1,000.
Yeah.
Where does it end? But
It seems very certain that it's not because it's autocorrelated. What's the certainty that it's not autocorrelation that you're finding?
We checked the correlations between the subsets of the variables independently, and they didn't seem to be autocorrelated.
But it ends up with the
The
same
clusters were the
cluster.
same. So the clusters that it would choose were the same, but the individual variables themselves didn't seem to be correlated.
No autocorrelation within the subset, but was there autocorrelation within the large set? So you might be choosing two different sets, but these are correlated with these in this second set.
I don't think they were. I think I can take a look at the details again.
But I think
I'm pretty sure they weren't,
we should-
and that was why I mentioned it.
Okay.
But it was a few years ago.
yeah.
Yes, can I ask, we should probably move on, but just a very different question. Just so I understood right, what you're clustering is the intervention kind, right? Whether it increases or decreases connectivity, basically.
Yeah, and the size, and if they have cycles or not, yes.
Yes.
So with that because that creates a let's call it absolute change, clustering. Have you considered trying to build a relative change clustering? That is, if these changes, conjunctive or disjunctive, are converging towards a kind of connectivity or level of connectivity, or if they are actually spreading into more or less connected areas.
So what you're saying is that they are getting more or less connected,
No, I mean,
independently of the closer to the.
I mean, if they are converging towards a mean connectivity, or if they are diverging towards differentiated connectivity.
No, I have not, but I will take that advice.
It's like